Hello and welcome to our maths lesson, and today we are going to continue with rates and ratio, particularly on solving rate problems. In our daily lives, we find change to be inevitable. Change is inevitable because in the daily life situation we do live in, things keep on changing. Heights of trees keep on changing. Weight of children keep on changing when they grow. Mass of items, especially living organism, keep on changing as time goes. We can look at the rate of change in many ways. We can ask ourselves, what is the rate at which a secretary who types, that is a typist, takes to type some amount of words? That is the typing rate. We can talk about laughing rate. How long does a person takes to laugh when he's happy? Talk of growth rate. A child is born, a child grows. There is a change every year. There is a change every given time in terms of mass, in terms of weight, in terms of height, and so on. Change is inevitable, and all the time, rate always applies. When we look at students, we ask them, what is the homework rate? You see, those students who do homework, some of them participate fully in doing all their homework. Others are lazy, they don't do all the homework. So we look at the rate of homework, how the students are doing it. That is change. We talk about rates in so many areas. Today, I want us to start solving this, what we are calling rate problems. Now that they keep on occurring in our daily lives, how do we solve them? How do we arrive at answers? How do we find or perceive what the change is going to be after a period of time? That is solving rate problems. So when a rate is given or is provided, now it means that a change in one quantity implies a similar or equivalent change in the other quantity. That's what rate says. A rate of change in one quantity implies that there is going to be an equivalent change in the second quantity. So it is a must that it must occur. Now let's look at this. Patrick earns a total of $20 per hour. Patrick earns $20 per hour. How much will he earn in 6 hours? Change. Look at the hours. Right from per hour, where we would be talking of saying that $20 in 1 hour. How will it be if we are talking of 6 hours? Question comes here. How many times has this 1 hour been multiplied by to give us 6? That is the rate we are looking for. And if it has been multiplied by a certain number, in this particular case, it is 6, then the other quantity, the same happens. The same changes applies. Therefore, for us to find the solution here and get how much is supposed to be paid in 6 hours. We shall multiply $20 by 6. You see? Equivalence of rate of change. There is multiplication by 6 on the side of hours to get 6 hours. The same 6 applies when you multiply $20 by 6. Therefore, question comes, how much will Patrick earn if he works for 6 hours? It's going to be 20 times 6, which is $120. That is what you are looking at, equivalence of the rate of change on either sides of the two quantities. The question also follows, if Patrick earns what we have here, $20 per hour, how much time does he require to work to earn $70? Yes, the question is that. So this time, we are not talking about the hour. This time, we want to look at the dollars. What has happened to the dollar? Initially, he is earning a total of $20 in 1 hour. So the question is, how long does he require or does he need to work so that he earns $70? Change, as I told you, that whatever happens in the first quantity, the same must happen in the second quantity. What happened for us to get the figure of 70 from 20? Did we multiply? Did we divide? What happened? For us to arrive there, it is very simple. Just take the new value that you have been given of 70, divide by the original value of $20. It will give you the multiple factor. So the multiplier in this case for us to attain this, we should have multiplied by something. And that is what we are looking for. And then it means that whatever that will happen on these sides of dollars, we shall go and apply it on the side of the hours. So then the question at your time, look at it. What has happened here? How suddenly can 20 turn into 70? What was multiplied by that? So you realize that the multiplication here is multiplied by simply 7/2. To get that, you can take 70 divided by 20. You'll get 7/2. 20, if you check out dollars, multiply by 7/2 by 2/1 by 210, it gives us $70. That is the multiplier. This is our interest. Therefore, we move to our right-hand side. We have seen that this, to get 70, we multiplied by 7/2. Take this one and multiply by 7/2. So the question now comes, how much time is he supposed to work? How many hours is he supposed to work to earn $70? And you'll get it is 7/2 hours. Simplified, it is equivalent to 3/1/2 hours. The idea of equivalence. The fact that rate of change of the first quantity, the first item remains the same to the second item. And as you are doing this and discovering that, so whatever happens on the right-hand side should happen on the left-hand side, put in mind the units. The units are very, very important. We said when we talk about rate, we are comparing the two quantities of different units. Therefore, the units must be stated. This case here, we have unit in dollars, another unit in hours. Both the two units must be taken into consideration. So as you apply the change on both sides, put in mind that the units always applies. And the units in this case, it is what? Dollars and hours. So we are now agreeing simply and saying units must be stated. And the units are coming up twice. They should be clearly listed in each question. So let us look at how to solve questions related to rate problems. So Rachel can touch Rachel can touch type at 74 words per minute. How many words can she type in 15 minutes? We are talking about solving rate problems. So let us just handle it very simple. How many words per minute? That is it. 74 words in 1 minute. Then what follows? The question is asking us to find how many words she will type in a period of 15 minutes. So what has happened to the time? It has been multiplied by 15. And I'll take that in consideration. By 15. In solving rate problem, we say that whatever happens to that quantity on the other side must happen to the other quantity. Definitely, we need again to multiply 74 by 15. That is what solving rate problems is about. When you multiply this, you'll find that in 15 minutes, we expect Rachel to type a total of 1,110 words. So we can conclude and say that Rachel can type 1,110 words in 15 minutes. That's what you are seeing here. So Rachel can type 1,110 words in 15 minutes. So we multiplied time by 15. And we went ahead and multiplied words by 15. Rate always works like that. Whatever happens on one quantity will happen on the other. In this question, we are looking at Lynn, who works in a donut van and sells an average of 60 donuts in every 15 minutes. So we have not been given it as a rate, but we have been given 60 donuts in average of 15 minutes. How long is it likely to take for her to sell 800 donuts. Now, we have looked at approaching questions in various many ways. We can approach it with fractions, we can approach it unitary. Basically, I want you to look at the unitary approach of solving rate problems. And in unitary approach, I'll want you to tell me if we are selling here 60 donuts in 15 minutes, what is the rate here? How much donuts can we sell per minute? That's precisely what they're asking us for. And that is the one which is going to guide us now to go through. Someone else would say, no, let us see how much donuts would be sold within 1 minute. And by the way, when you look at that, then you will find that, are you able to sell a fraction of a donut? Doesn't exist. So when you go for unitary method, you don't just pick on any one unit and say that's how you're going to go about it. Sometimes it should make sense. And that's why, look here, I'm not going to say then, because I'm looking for 800 donuts, let me find out. Let me find out. If, 1 minute, I'll be selling several donuts. Then somebody say, no, $1 donut is being sold an average of how many minutes? I don't know. Which is which? So unitary my approach. So I'm going to look at it from the unitary point of view. Here, we have $60 donuts in 15 minutes. Question is asking us for 800. We can go straight, but I want us to use unitary first and see, is it workable? Whereby I would ask myself here, 1 donut averagely is sold within how many minutes? Or let us first engage this and get the rate of donuts per minute and see. So, if you want to find how many donuts you will sell per minute, you will divide this by 15. And the same will apply on the left-hand side. You find by 15 is, so we are talking of 1 minute is 4 donuts. You see that? But they want 800. So, if I take this and decide to say, what is the average time in minutes does 1 donut take to be sold out? Look here very carefully. I'll find that 1 donut I'll divide by 4. Therefore, 1 donut, whatever happens to the left must happen to the right, will take a total of 1/4 minutes. We know units of change. You can say this is equivalent to 15 seconds because 1 minute is 60 seconds. But now, here we are. We have reduced from 60 in 15 minutes, come to 4 donuts in 1 minute. Now we have found the rate of selling 1 donut is 1/4 minute. Let us keep it in minutes. And then we shall do the conversion later on if necessary. Otherwise, 1/4 minute is that. So the question is, if 1 donut is 1/4 minute, how about 800 donuts? You see? That means we are multiplying here by 800. Okay? This is 800 donuts will be equal to 1/4 minute multiplied by 800. By 4, 1 by 4, 200. And the answer in units is in minutes. So we are seeing here that, I'll write it here. We are now seeing that 800 donuts in 200 minutes Let us go back to the question. How long is it likely to take her to sell 800 donuts? This question requires some decent reasoning. To look awkward for you to leave your answer, it's correct, yes, but you're talking of 200 minutes. For someone who has gone to school, what should you write instead of writing 200 minutes? You will convert 200 minutes into hours, even if it's going even into days, as long as you give it in your simplest way that is easily understandable. So convert these 200 minutes into what? Into hours and minutes. So we say that 1 hour is equals to 60 minutes, right? Then how many hours are there in 200 minutes? It will be 200 divided by 60. The remainder we shall see what to do about it. So 200 minutes will be equal to how many hours? It will be 200 over 60 multiplied by 1 over 1. When you do this, 60 goes into 200 how many times? It goes 3 times because of 180. So this is 3 hours. Remainder 20. 20 is minutes. Now, this is logical. 3 hours and 20 minutes, but not 200 minutes. Or you can say 3 1/3. 3 1/3 hours. It's allowed. So it will take Lynn 3 hours, 20 minutes to sell about 800 donuts. Right? This question, I want you to read the question very, very carefully and take it, because I'll be working from the same space. So we'll go through the question and then we'll rub so that we can use the same space to do this particular question. So make sure you take it down. 3 water hoses from 3 different taps are used to fill a large swimming pool. The first hose alone takes 200 hours to fill the pool, and the second hose alone takes 120 hours to fill the pool. The third hose alone takes only 50 hours to fill the pool. How long would it take to fill the pool if all the 3 hoses were used? If all the 3 hoses were used. Now, previously, we saw the idea of what we call lowest common multiple, or and this is what we call LCM. Now, we are looking at the time taken, that is 200 hours, 120 hours, and 50 hours. We are looking at that. Now, when you come to this, now, when you look at this, we want to fill this large swimming pool. And we find that here, if we want to get 1 hose filling the pool, now, before we respond to this, you see that when you look at this, I was telling you about what I'm calling the LCM. That is the least common multiple of all this. If you are very keen, it is 600. And that's why now from the 600 we are looking at horse 1, which takes how many hours? 200 hours, isn't it? Now, if that is the case here, it would fill how many pools? 3 pools. Because the rate is 200 hours and the LCM is counting on 600 hours. If it was horse 2, it would take 600 divided by 120. This would fill 5 pools. So we are using the LCM to see how to approach this. And I'll repeat this. The least common multiple for 200, 120, and 50 is 600. So using the 600 here as a common multiple, we find that, see, with 600, horse 1 can fill 3 pools. With 600, horse 2 can fill 5 pools. With 600, horse 3 can fill how many pools? Can you tell me how many pools would 600 horse 3 fill? So you'll find that it will be 12 pools. How are we getting this? We have said it is our least common multiple, which is 600. Remember, we are talking of hours because this is what? Issue about rate, so the units are very important. And then this one divided by what we have, which is 200. Again, you find that the 200 is hours. It will give us the number of pools, because from this question, 200 to fill the swimming pool, 200 to fill 1 swimming pool, so 200. If it is 600, there will be 3 pools. That's why we are getting the 3 pools here. That's why we have this. Same applies to this, same applies to that one there. Now, this is what we have from our least common multiple of 600. We've been able to know what every horse would do to the number of pools it is capable of filling. Now, so supposing we are talking of, look at this clearly, supposing we are talking of all the horses remaining open, then we shall be talking that in 600 hours, how many pools would be filled by these horses? We say that 3 horses would fill 20 pools. 3 horses would fill 20 pools. How are we getting 20? It is 3 plus 5 plus 12 gives us 20. How are we getting 3? It is horse 1 plus horse 2 plus horse 3. 1, 1, 1. These are 3 horses. That's why we have that 3. Now, this is where we are. We want to bring in the idea of rates. Where the idea of rates, we need to have the quantities clearly stated. We need to have the units clearly shown so that we know what exactly are we looking for. The question that we were supposed to answer was saying, how long would it take to fill a pool if all the 3 horses were left running or were put on? So the question now is what we call the filling rate. At this part where we have the horses is not our point of interest. Why? Because we already have 3 horses and the question is asking us, open them, all of them, open them. Therefore, the filling rate is this, 600 hours, 20 pools. That is the filling rate we are looking for. 600 hours, 20 pools. So the question was, how long it would take to fill the pool. Only one pool is our rate. So for us to get one pool, then it will mean now we have said for the issue of horses is just the number. Oh, when these horses are all left running, then we are talking of 600 hours for 20 pools. How about one pool? We would divide this one by what? By 20. So that we get one pool. And this one would give us one pool here. And when you divide hours, then it is going to give us how many hours will it take all the 3 taps to fill one pool. So we divide again by 20 here. Well, so when you divide 600, divide by 20, what do you get? So you'll find that this one will give us 30 hours to fill one pool. Remember, what is happening here, it is for the 3 horses. So 30 hours for 3 horses to fill one pool. So what is our rate? Our rate is simply 30 hours per pool. 30 hours per pool. So in this question, we can conclude and say that so we can finally agree that it would take 30 hours to fill the pool if all the 3 horses were left running. So what is important is how we approached this particular question until we found how many pools can be filled. That is very, very important. And then the issue of 3 horses, I've said we've not used the 3 anywhere in the figure here because our interest is for the 3 horses to be left running. We need to find out the time taken to fill one single pool. That is what we were looking for here. So in general, you'll find that when you talk about solving rate problems, the idea here is that whatever that happens on either side must be the same on the other different side. So let us look at further questions on rates, solving combination rate problems. A factory produces 40 plastic bottles per minute. How many bottles can the factory produce in 60 minutes? 2, how many bottles can the factory produce in 8 hours? So here is a matter of looking at our rate and then looking at what we have. For this one, is straightforward. We are looking at $40 plastic bottles in 1 minute. Now, if they ask for 60 minutes, definitely it has given us what are we going to multiply by. So this side we shall multiply by 60 to get 60 minutes, which is equivalent to 1 hour. And this other side, how many bottles will be produced here? We multiply 40 by 60 again here, and you find 40 multiplied by 60, you get it is 2,400 bottles in 60 minutes. So, because as I told you earlier on, we are conversant with the conversion of units, so there's no need for us to maintain 60 minutes because we know what it means. So we simply change this and say that this one is equivalent to 2,400 bottles per hour. right? 2,400 bottles per hour. That is the rate per hour. But if it was we were talking about minutes, we would only say 2,400 bottles in 60 minutes. But per hour, this is our rate. The question goes ahead and asks us to find how many bottles would be produced in 8 hours. If we have come up with the rate per hour, then for 8 hours it's not going to be a tough approach, because we already have an hour. So on the right hand side where we have the hour has been multiplied by 8 to give us 8 hours. So we are being asked how many would we get, how many bottles would we get in 8 hours. So this would be 2,400 multiplied by 8. And when you do that, this one is 32. It will give us 19,000. It will give us 19,200 bottles in 8 hours. It's not a rate. Bottles in 8 hours. That is 2,400 multiplied by 8. So we have Mario, who is a professional home painter. When painting a new home, he uses 2.5 liters of paint per hour. 2.5 liters of paint per hour. How many liters of paint would Mario use in a week? How many liters of paint would Mario use in a week if he paints for 40 hours? If he paints for 40 hours. Now, before we start this question, there is an interesting part they have brought. They are talking about in a week, but they have told us how many hours Mario is going to work in the whole week. So definitely now we are going to concern ourselves that the total number of hours worked out here in a week are totaling to 40. So it doesn't work all the days, all the hours. But the point is certain hours. But in a total of 1 week, he has worked 40 hours. So we start by looking at the rate that we have. The rate that we have per hour is 2.5 liters per hour. That is our rate, which means 2.5 liters in 1 hour. Now, a week, he works for 40 hours. So they are asking us to find how the liters of paint he uses in a week. How many hours did he work that week? It's 40 hours. So we are going to multiply hour by 40 and not just write down that's 1 week. Neither are we going to say 1 day has got 24 hours, 1 week has got 7 days, so multiply 7 by 24 hours. No. We have the hours that were worked in 1 week. So 40 times 1 is 40 hours, right? Then 2.5 multiplied by 40 will give us what? That one will give us a total of 100 liters. So it is 100 liters in 40 hours. But what is this 40 hours? That is 1 week. So we can change and now say it is 40 liters per week. Why I've said per week? Because his week, he works for only 40 hours in a week. Therefore, it's equivalent to say just 100 liters per week. That is the rate they are asking us to find in this case. Daniel practices his guitar for 40 minutes every day. 40 minutes every day. How many hours will it take him to log up to 100 hours for practice? We need to correct that question. It's not how many hours, how many days. Will it take him to log up to 100 hours for practice. And 2, how many days will it take him to log up to 10,000 hours of practice? How many days will it take him to log up to 10,000 hours of practice? So looking at the first one, it is every day only 40 minutes, not hours. So our rate, we are talking of 40 minutes per day, which is simply 40 minutes in a day. Then the question becomes, how many hours? Now, we can approach this question interestingly. There's nothing wrong if we choose to change, because our question requires us to deal with hours, change the 40 minutes into hours. So, besides this outside here, I'll say 60 minutes is 1 hour. 40 minutes will be 40 multiplied by 1 divided by 60. We will find that this one will give me how many hours? 2/3 hours. That is 4/6 or 2/3 hours. Now I'm going to use hours to work on this. So this one is equivalent to 2/3 hours, 2/3 hours in a day. Or 2/3 or 2/3 of an hour in a day. So he practices for 2/3 of an hour every day. Then the question now is asking us for 10,000. For the first part, it's actually asking us for 100 hours. So everything is in hours. We have converted from minutes to hours. Now we are ready to go. So if 2/3 of an hour a day, that is his practicing time, what has happened here to give us 100 hours? So you realize that for us to arrive at that, it is like taking 100 divided by 100 divided by 3 by 2/3, which is the same as 100 multiplied by 3/2 by 2 is 1 by 2 is 50. This is equals to 150. Is it true that 2/3 times 150 equals to 100? By 3 is 1 by 3 here is 50. 50 times that one is, so we are getting. So what is the multiplier here? So 2/3 multiplied by 50 this side. Because that is per day, go to a day also and multiply by 50, which will give us 50 days definitely. Therefore, we are saying that it will take 50 days. Therefore, it will take 50 days for Daniel to log up 100 hours. So for Daniel to log 100 hours, it will take him 50 days. 50 days, 100 hours. So when we move to question 2, put in mind what we have. How many days will it take him to log up to we have 10,000 hours of practice? So the approach there, so this one we are done. For 100 hours, you are talking of 50 days. So now we are going for 10,000 hours. For 10,000 hours, what are we supposed to do? Remember everything, we want to find out the number of days. and this other side we have number of hours. The question you have been given in minutes. So as we saw earlier on, we said per day it is 2/3 of an hour in a day. To log up to 10,000 hours in how many days? To get what we shall multiply by here, first you will take this divided by that, which you will find is them as 10,000 multiplied by 3 divided by 2, which is 1,500. So times 1,500 here, times 1,500 here. So you can just confirm, if at all. Let us just confirm if we have it right. 2/3 2/3 multiplied by 1,500. I need to correct that, but this one is 1, but this one is 500. This one gives us 1,000. So we are missing 1, which is supposed to be 15,000, not 15,000 and not 1,500, not 1,500, but 15,000. So let us again confirm that that is 1,500, 15,000 multiplied by 2/3. So by this one will give us 1, this one will give us 5,000. 5,000 multiplied by 2 is 10. So we have the multiplier there. Now we can move ahead. So, as we said earlier on when we are solving these questions of combination, whatever happens on one side must happen on the other side. For us to move from 2/3 of 1 hour until we arrive 10,000, same that happened here should happen to the number of days, and we are seeing it's multiplied by 15,000. So when you multiply 2/3 times 15,000 is 10,000. And then this other side, we have 15,000 days. Logically, we cannot talk of 15,000 days. It's good to simplify and find out how many years are these, or how many weeks, or how many months. We are allowed to divide all that. If we were to change into years, we say 1 year is approximately 365 days. Therefore, how many are there in 15,000? In 15,000 days. So, let us see which one we shall adopt. 15,000 days can be changed into weeks or months or years. If you choose to, if the question is just asking straight for how many days, this one is easier because it's asking for how many days, so we shall leave it at 1 or 15,000 days. But if it was asking for how many years, we would take this and divide by 365. If it was asking for how many weeks, we would take this and divide by 7. So the unit of conversion, days into weeks, weeks into months, months into years, we should be able to convert that at any given point. So in this case, we are saying for Daniel to log 10,000 hours of practice, then he needs to practice for 15,000 days. In this question, we are asked to find the cost. So what is the cost of paving a driveway measuring 18 meters long by 4 meters wide? If I may illustrate, and we have the cost. The cost per square meter is $35 per square meter is $35. So we are being asked to find what is the cost of paving a paveway that measures 18 meters by 4 meters. So this is a rectangular look, so we are supposed to approach it from the area point of view, which is the length times breadth, which is 18 multiplied by 4. So if that is the case, then you'll find that 18 multiplied by 4, you'll get 100 and you'll get 72. So this is 72 square meters. Now, from this is just it. We have to pave an area of 72 square meters. And 1 square meter is simply 35. So what is supposed to be the total cost for paving across all this? Because this is what we have to pave. Now, if you look at 1 meter square is like a small box like that. And we have 4 of these times this way and 18. So in other words, we now bring in the rate and ratio issue, and we shall see that it takes, for us to pave, it costs $35 to pave 1 square meter. How much will it cost to pave 72 square meter? So for us to reach a 72 here, we should have multiplied by 72. So again, this side multiplied by 72. So we find that the answer will be 35 multiplied by 72, and it should be in dollars. When you use your calculator, so you'll find that to pave that particular pave, you will use a total of $2,520. That is simply because for every 1 meter square, we are spending a total of $35. And the paved way has got a total of 72 meter square. That's why we come up with that. So by that example, we come to the end of the lesson today. Thank you.